You got the handout, right? Did you get it?
No, ma'am.
No. Okay. Let me see. Okay, I'll send it now. I'll send it through the chat. See whether you can access it. Yeah, I've sent it. I've sent a PDF file actually through the chat in Microsoft Teams. Uh, did you get it?
Yes, ma'am.
Okay. So please share this with the other people also. Uh, okay. So we actually talked about the basics of R programming. Uh, I hope you could install R in your machine, R Studio in your machine. I think there was no issue while installing it because it is not a very big application and it is you don't require much of settings for installing this R Studio. You can just simply install it. And last week I actually showed you how your R Studio workspace uh, looks like. So it is like this, right? So remember I mean you are working with you normally work with uh, certain variables, arrays, lists, and stuff, and all of those objects get created in your global environment. So if you want to um, save your workspace, I actually didn't save my workspace on the other day. So if you want to use those arrays and lists and all the globe objects which you have created here, you have to save it, right? You have, when you are putting your RStudio application, you have to save your workspace. You can save from here, and you can access all those objects when you open your application on another time, right? Otherwise, all the objects that you have created will be discarded. So remember to save your workspace when you're closing the application if you need to use those objects again and again. So here is the environment tab, and you also have a history tab here. So in this history tab, you can see you will be able to see all the actions, all the functions, and everything that you have done in your console, right? So when you're doing all of them, those actions will be appeared here, right? So the last week we actually talked about the very basics about like creating variables and lines lists and arrays. So basically in R, we use vectors, lists, matrices, and arrays. So those are the main storage locations. So what we are doing here is we get the data, we store the data in a particular way, either in a variable, in an array, in a list, like that, as a matrix. And then we use those data to do some analysis so that we can come up with certain decisions, right? So we also have something called the assignment operator. So it is very basic to assigning things in other programming languages. For example, in C or Java, we normally create a variable and then we use the assignment operator, which is the equal operator, and then we assign whatever value that we want to assign to that particular variable. So in other programming languages, we have to define a data type, sometimes even a size of the variable or an array. But here in R, we can simply write the variable name and we can assign the values. So when we are assigning values, the size of the variable and the type of the variable, the data type of the variable will be um, initiated, right? Instantiated. So we have the assignment operator where this variable, so this when we write something like this, this var1 variable will include an array of characters. So since we have written C here, so it will be characters. So there will be an array of characters included in this variable, right? And we also have the assignment type of assignment using the leftward operator. So we can also assign values using this operator. This operator means this is the greater than or less than sign and a hyphen. So here also we can assign. So here we have assigned a character array again, which consists of certain strings, right? An array of strings. So since this is these strings will be a collection of characters, we can simply type as C here. So this variable will be, the data type will be character and the values will be assigned. So this will be the output when we print it, right? We also can use the rightward operator like this. It is the same of this leftward operator, but it is the side is different. So true means the it is a like a conditional thing, so it will be either 1 or 0. So when we print this true, it will be printed as 1, right? And another one is here. So these two values will be printed like this. Okay, so that is very a simple example of using the assignment operator, using the assignment, right? Okay, so next we move on to the very, it is also the basics, but it is very important because we are able to do certain analysis using these functions, right? Okay, so before using these functions, I'm going to show you how we can import a data set to RStudio. So you can simply import a data set from, you have this option called import data set, right? Under the environment tab, you have this option called import that data set. So you can import the data set either from a text file uh, or an Excel file, from an SPSS set of data, right? From SAS, statistics, or like that. So there are different kinds of data sets that you are able to load in RStudio. So that is the easiest way. Or otherwise you can type this in your console. So this is the assignment operator, if you can remember. Then we have to load, if we have a CSV file, we have to load read.csv. We have to use the read.csv function, and you have to give your file name, right? Inside inverted commas, you have to give your file name with the extension, right? So when you load this file, it will be loaded into your environment, in your global environment. Then you can use that. So X is like a pointer. You can refer to this file using the variable X, right? You can refer to this file using the variable X. And if you want to include the file, the data in the file, into a matrix for your calculation purposes, then you can use this data.matrix function to load the data inside the CSV file into a matrix, right? So remember, not if you change the things in this matrix, nothing will be affected to the file. The file will not be affected. So normally, this is like a best practice. Normally, when we load a file to our environment, we point or we take the data from that file and load it to either a matrix or an array or a list or any data type that you want to work with, right? So, here you can simply import the data set from a file. So if I click to import it, there are some updates. Okay, so under the household size, let me see whether I have that file with me. I think I do not have that particular file with me. I'll just show you this. I'll just add this file. So when you add in the file, a sample will be shown to you. So there are certain settings you have to since this is a CSV file, you have to mention whether it has a heading, a header, then how to get the row names and what is the separator, whether it is a tab or a comma or semicolon. And you have to mention how the decimal point is being mentioned, either using a period or a comma. Then how the quotes are being used, whether it is a double quote or single quote, or whether there are no quotes. You have to mention whether there is a comment in the file. There are three comments, like that, right? So you can just simply click on this and you can import the file. So you will be able to see the file which is being imported. So this is the file with the file name, right? And you have to, as I have mentioned here, you have to point, or you have to get the data into a variable, not a variable actually. You are like referencing, you are creating a variable to refer to the file, right? Otherwise, we will have to type the file name again and again if you want to. So you can see here the last, uh, what do you say, command which is available here is view, and then the file name, which means you can see, or you have loaded the file into here, right? So view is the command. So you will need to mention this file name again and again if you do not add this kind of a reference, right? So I'm just typing, and the assignment. Yeah, I'm going to type read.csv, and inside the inverted quotes, I'm typing the file name. So okay. Oops. See whether I have loaded the text file, I think. Mm, this is I think this is because it is a text. It has been saved as a text file. So I'll just save it as a CSV file. Okay. So let me save this as I'm going to save this as a CSV file. Okay. Okay, so this file is already loaded. I'm sorry. So the thing is, when you import the data set from here, it will already be loaded to the environment, right? So I'll just um, so here I have loaded the files to my environment. So this read means you can import from the um, from whatever location to your environment. So read.csv is that, and you can load the data into a data matrix using this data.metrics function, right? So I'll just type data dot matrix, and you can simply type the file name which has been loaded here. So yeah, you can see this is Z. Z means this is the matrix. So you can see a large matrix has been created. So you won't be able to see all the elements here because it is a very large matrix. So all the objects, all the elements of this table have been inserted or included into this matrix. So this is the first row, ID, flag, tsunami, all these things. These are the first row. And there are this amount of elements in the matrix, right? So when you are, like, if you want to do some analysis, you can do the analysis using the matrix. So when you analyze the data, or when you maybe sometimes you will be needed to change the data, so you can do anything for the matrix, Z matrix, right? Otherwise, it will be affected to the original file, right? So like that, remember when you are dealing with the with all the data, you will have to make a copy of the data, uh, most probably into a matrix. Okay. So you can view the data in the console. Uh, so the file name, if the given file name is this one, when if you type simply str or the string and give the file name, then you will see the data in the console, and you can have a summary, right? You can have a summary of the data. Uh, so you can simply type summary and the file name, right? So if I type str and give the file name, or simply give the matrix name, let's see. Yeah, so only the particular uh, kind of a summary will be given to you. So you can type the file name if you want. Yeah, so when you type the file name, all the data will be shown here, right? So here the column names will be shown here, and the data type of each column will be shown here, and the data will be also shown here. So this is also is kind of a summary, because all the data won't be able to fit in this console. So kind of a summary will be shown to you, right? So it is a much more detailed summary than just using the matrix name, right? So you can uh, type the file name here under the str command, and you will be able to see a much more detailed summary here. Okay. And yeah, you can again get a summary. It is like a statistical summary. You simply type summary, and you can give the file name. So here, yeah, uh, under each and every column, Okay. Under each and every column, you will get a kind of a summary. So for example, if we take around if we take this column intensity, so if you can see, there's a column called intensity. So the minimum value is shown here. The first quadrant, the median value, the mean value, the third quadrant, and the maximum value. So number of not availables will be this number. So you can see, you can get a summary. So this data is regarding tsunami data. So here we are measuring the intensity, maybe the intensity of the earthquake, like that. So the minimum intensity will be 2. The median intensity will be 9. The mean or the normally usual intensity will be 8 point something, and the maximum intensity value recorded is 12. So number of not available data is 3224. So you can get a summary of each column, right? So this summary is given regarding numerical data. But here you can see, if there are character data, you won't be able to identify much of, you won't be able to get much of an information, because they do not convert this character data into character analysis, right? Character based analysis, or for example, this country. So there are here under this column, the names of the countries will be appeared, but they do not like count the number of same characters or number of same strings, things like that. They do not count. They have counted the characters, number of characters, but this numerical statistics or the numerical summary won't be much useful for character based uh, columns, right? But for numerical numbers, it will be very important. So for example, when we take deaths, under the deaths column, the minimum number of deaths are 1. The maximum number is 8 million something, right? So the numbers which are not available or not recorded is also given. So like that. So injuries, right? Damages. So all the kind of a summary will be given to you, right? So these summaries comes under each and every column, right? So you can use that function to view data in the console, and to get a summary, right? Okay, so next we come to R functions, uh, right? So R functions means it is very similar to any other functions which are created in other programming languages. I think if you, I hope you have created functions in other programming languages like Java, C, C++. I don't know what programming languages you have done previously, but I hope you have done at least one programming language during your academic time. So every programming language has functions, and so do R. Um, so in R, function is basically like this. So there's a function name, and there is an assignment operator and the word function. So this word function mentions that this is a function. So you can have an argument list, same as any other programming language. You can have an argument list, and inside the curly brackets you can have the function body, right? Inside the curly brackets you can have the function body. You can write the function body, right? So the function name and the keyword function, the argument list, and the function body. So that is the simplest or the basic basic structure of a function in R. So there are different function components, as I have mentioned here. So first is the function name. This is the actual name of the function. This function name is stored in the R environment as an object with its name. So when you create a function, an object, a function type object will be created in the R environment, and you will be able to see the function name in the R environment, in the global environment of R. So similar to creating a variable. So whenever you create a variable, that variable name will be appeared in the global environment. So here also the function name will be appeared in the global environment. So the argument list is it's kind of a placeholder. You can pass values to these arguments. So when the function is invoked, you can pass a value to the argument. Arguments are optional actually. You do not have to pass values every time. But if you can remember, so for example here, summary is a function, and here we are passing the file name, passing our file name as an argument list in the argument list. So as an argument, we are passing the file name, right? Uh, so a function might have an arguments or no arguments. Also, arguments can have default values. So we can pass a default value, or we can pass a default value to an argument through a function. Then comes the function body. The function body is actually how the function is functioning, right? How the function is working. It includes inside the function body. It contains a collection of statements that defines what the function does. So what the function is doing, it depends on what is inside the function body. Then you can have a return value. So the return value of a function is the last expression in the function body to be evaluated. So you can return either a string or any argument or a list or a matrix. You can return anything. So if you see here the summary function, it returns the summary of each and every column. You saw in the console, you saw that when we type this function name, summary function name, the summary of each and every column is being returned. So that is the return type, the return value. So here the return value means the summary of each and every column, right? So that is the return value. The summary of each and every column is the return value. Okay. Right. So that is the basic structure of a function. Then there are built-in functions. So built-in functions means there are already created functions inside R Studio or R. So it simply makes our lives easier. So we do not have to write everything I mean we do not have to create new function bodies. We can just simply use what they have built and use for our purposes. So simple examples of inbuilt functions are uh, seek, mean, max, sum, paste. So you can try them, right? So some functions you will be able to understand what those functions will function. Some you might not understand. So some might have certain statistical information. Uh, so you can directly call these functions into your program. You can refer most widely used R functions. Yeah. So there are some functions are widely used in R. So for example, you can see here this uh, function or a sequence. The sequence function, you can create a sequence of numbers from 32 to 44. Just a random, just the sequence of numbers you will be able to create. And print is also a function. So the print function requires something to be printed. So what I am including to be printed is this sequence function, right? So you can type like this. Print, and we can use the sequence function. So I am typing 10 to 40. So you can see here the sequence of numbers, right? The numbers one after another. So there's a sequence. These numbers will be printed when we type this function. So this is the sequence of numbers. So you can like add like this. Then numbers from 10 to 400 will be printed, right? Uh, so we can find the mean of numbers from 25 to 82. So you can give a range, a number range, and you can find the mean value, right? So mean is also a function, an inbuilt function. So mean can be used in your statistical analysis part, right? So this is how you are going to type it, print mean, and you just give the set of numbers. So mean value from 20 to 30 will be 20, right? 20 plus yeah, not a comma, it should be yeah. So mean from 20 to 30 will be 25. So like that you can find the mean value of any number range, right? And you can also create, you can calculate the sum, right? Sum of numbers. So the summation from numbers 41 to 68. So that is the example given here. You can just simply type print, and you can use the function sum. So I'll just type 30 to 50, right? So the summation will be, I'm sorry, yeah, here also it should be so 840 will be the sum of values from 30 to 50. So you can check it out, right? So you can add 30 plus 31 plus 32 plus like that. You can add all the numbers and see whether you get this answer correct, right? So that is those are some simple those were some simple examples of inbuilt functions of R. Uh, so similarly, there are some other functions that I have given here. So you can use those functions in your file, the data set that I have loaded, if you can remember, right? So you can use the file name here, or maybe the variable name. If you have assigned the file to a variable, you can use the variable name also. So here the file name is actually avg.household.size. That is the file name. So instead of the name, you can use the matrix, right? So I have sent you this handout, so I'll just give you a little bit of time to go through up to this point here. So yeah, so here also there are some functions. Yeah, we'll come to this part later, creating histograms and box plots and those stuff. We'll come to them later. You just simply try to load the file into your working environment. You can either use this you can either use this read.cxv command, or you can import the dataset from here. After importing the dataset, you can create a matrix and point to a variable, right? Then you can view the data in the console, and you can create functions, right? So there are several inbuilt functions. So you can see here there are several inbuilt functions. So what I really want is for you to go through these functions and see what they are calculating, right? Uh, you can try these functions and see what they actually do, right? And how the results will be provided. So I'll just give you a little bit of time for you to practice and see whether you have any issues. So if you come up with any issue, please let me know. I'll give you around 10, yeah, around 10 minutes to uh, practice with this and be familiar. Okay. So let me know if you have any questions. Okay, so did you were you able to come up to this slide? Did you have any issues?
Yes, ma'am.
Yeah.
Can you please give an example for hist? How to use hist term?
Hist means yeah, I think it is the histogram thing.
Histogram. Yes.
Yeah. So I think yeah, let's see. So histogram means you will need a little bit of data here. So I think I have included around 4 data, and you can uh, so first of all, histogram counts when you're creating a histogram. It counts the similar type of data, and it resembles how many how I mean for what for one type of data or one uh, yeah, one type of data, how much or how many times that data is included or that data appears is mentioned in a histogram. It is like a count. So for example, if you have the number 10, so how many times this number 10 has been included in your data set is being uh, shown in a histogram, right? So you can have a number or maybe a data range. Okay, so how much of that data is being included in the data set or is being found in the data set? That information is given to you in a histogram. So here I have included four numbers. So you can uh, simply say uh, so to include. So here I have created an array of data, an array of numbers. So here numbers 1, 2, 3, 4, 5, 6, 78, 8 and 8 are included. So there are 9 numbers here. 9, 9, right? Yeah, 9 numbers are here. Right. So if you want to, so let me see, let me give you the summary of these numbers. So you can see the minimum value, the maximum value, and the medians, means, and quadrants have been mentioned here. So if you type histogram, so if you are using histogram, you can see here the description mentions the generic function. Hist is the generic function which computes a histogram of the given data values, right? Uh, yeah, so if I use this hist function and use the x uh, variable, so it will take these values that I have included 1, 2, 3, 4, 5, 6, 78, 8 and 8 and create a histogram. So here the frequency, this side they have shown the frequency, okay, and the data range so here they have taken a default range because I have included numbers from 1 to 78. So they have taken numbers from 0 to 80 because it covers the number sets from 1 to 78, and they have divided uh, up to several parts or several data ranges, number ranges. So from 0 to 20, 20 to 40, 40 to 60, and 60 to 80. Right. So this, if you can see here, the 78, the value 78 has been used once. Only 178 is here. Right. So numbers between 60 to 80, which includes 78 only, is used one time. Right. So 1, so you can see here, this comes to 1 for one time that number is being used, or one time this this number range is being used. And all the other numbers which comes inside the range 0 to 20, so you can see all the other numbers falls under the range 0 to 20. So the amount of the other numbers which is being used, I think it is 8 times, right? So apart from 78, all the other 8 numbers, all the other numbers have been used 8 times. So since this is a range, this range is being increased up to 8. So the frequency, right? 8 times means the frequency. So numbers within 0 to 20 has been used. The frequency of the usage is 8. Numbers between 60 to 80, the frequency of the usage is 1. Right. So this is a default. I mean, defaultly they have taken the the number range and the frequency range. Right. So if let's see if we are using the numbers. Yeah, so I'll create a sequence of numbers. This variable y, I'll include so this is rand u means it is a correction of 400 random numbers, I think. Let's see. Okay, so y is created. So you can see here y, it has some random numbers, right? So how these random numbers are created, you can see in the description of the when you type like this, it comes under the description, right? 400 triples of successive random numbers were taken from this from whatever this function, and so those random numbers are included in this function, right? So I have included those random numbers in this y matrix. It is kind of a matrix. It is a 3D matrix, I think. Let's see whether we can include it in our histogram. So if I just type hist and include y, let's see. Okay, so since it is a yeah, it is not given as numeric. So I just used a sequence of numbers. So see how we can use random numbers in R. Okay, I'll just simply type a sequence. So y equals sequence from into so you can see here y has been replaced by my new number set. So this is a sequence of numbers. So if we use this sequence of numbers in our histogram, so you can see here. So obviously, the all the range. I mean, since there we have from 10 to 100, if you divide those numbers into a range, equal amount will be spreaded. So since this is a sequence of numbers, so here you can see a histogram created. So the frequency of each range has been shown here. Okay, so did you get it? You can use a very yeah, you can use these other functions also and see how the histogram is being created. So this first histogram, they take the, I mean, they take the numbers and they analyze, R itself analyze it, and it creates the data range and the frequency range. So in the second function, with the arguments here, you can see, I mean, you can include the values for the labels, and yeah, so you can give the name for the histogram. I mean, you can customize the view of the histogram, right? From this second way. So the value, so the number set will be X, right? So the titles and the X-axis, Y-axis, those names you can customize. And this box plot is also a way that you can represent data, right? Uh, yeah. So this R norm is also kind of a normal distribution. Let's see. Yeah, it is kind of a normal distribution of numbers. So if we give kind of 100, then yeah, a normal distribution of 100 numbers from, yeah, it will be shown. So if we type print and y, so remember I am replacing y with the same numbers again and again. Yeah, so this is also a set of numbers. So if we create a histogram using this set of numbers, let's see how it comes. Yeah, so here the range goes from -2 up to +2. So since this is a normal distribution, it falls under this number range, -2 up to +2. And the frequency, how many numbers or how many times the numbers between, for example, from 0 to 0.5, how many times frequency here, which is 20. Okay, so this is the histogram which is related to this normal distribution of normal distribution of these numbers, right? Okay, so histogram represents the frequency of some numbers or maybe a range of numbers. So it is like when you have a very large set of numbers, you will be able to see how much, I mean, you can see the highlighted number or highlighted data using a histogram, right? Did you get it?
Yes, ma'am.
Okay, so a box plot is also a representation of numbers, a representation of data. You can represent like a summary, a visual view of a summary of data, right? So if I type box plot and if I give this, sorry, y here, you can see the distribution in I mean distribution from -2 up to +2 is given here, and the amount of data or how much what is the range of or the maximum range of data is shown here. So you can see how what a box plot normally shows, and according to the data range or according to the data that you have with you, you can either create a box plot or a histogram in order to justify your answer in your assignment. Okay. So whenever you create these charts, you can always export this chart. So you can save this chart as an image, right? Or maybe a PDF, or you can copy to the clipboard and paste it in your document, right? So when you are, I mean, after you analyze the data and when you are creating your report, remember to include a visual representation, maybe a histogram, maybe a box plot, maybe a pie chart, maybe a bar chart, any way that you think that the data will be easily understood, you have to represent it, right? So okay, so there are some other charts that I have that I need just to show you. Yeah, so you can always go to this tutorial point. I think I have included that tutorial point link here on the last uh, slide that I have given to you. So this tutorial point has got some interesting examples and easy to study examples. You can go and try them. So in this tutorial point, you can see here there is a section called charts and graphs. So they show how to create certain charts. So for example, you can create pie charts, right? So the syntax is given to you. The keyword is pie, and the first variable is the data set, similar to the way that we have created our histogram. So this is the data set, and you can give the labels. You can give the radius for the pie, how the size, uh, the name, the columns, and columns which are included, and sorry, not column, the color, and whether the pie chart is created clockwise or anti-clockwise. Sorry. So here you can see the description. X is the vector, or X is the data set, the numerical values that you are using to include in your chart. Labels are to describe the slices or the sections of the pie chart. Radius means the radius of the circle of the pie, right? So the values will be between -1 to +1. Uh, Main indicates the title. What is the title of the chart? And the color palette which you can use. And this clockwise indicates the logical value, indicating if the slices are drawn clockwise or anti-clockwise. How the slices of the chart is being drawn is shown here. So there is a simple code here, right? So a set of data is given here. The labels are also given. So you can give the chart a file name. So this is how you are going to plot the chart. So pi is the keyword, and then you have to include your data set. So X is the set of data, and then the labels for each and every data. What is the label? So for 21 is this London, 62 New York, 10 Singapore, 53 is Mumbai. So the chart will be shown like this. So how the default values, the other ones are default values. So clockwise, the how this chart starts. So from London, then New York, Singapore, and Mumbai. So it goes in a clockwise way, right? Okay, so if I just type this, so I'm giving let's say A. So I'm just using the assignment operator like this. So remember, all of these numbers should be, the summation should be equal to 100, right? No, they will get the percentage. So just the numbers, I'm going to include this. Okay, these are the numbers. So my A variable is being created. Then I'm going to give the labels. So I'm just typing labels. So I'm labeling the first one as, let's say some fruits. Apple. So there are 5 fruits. Banana. So I have given a random set of labels, right? So 5 numbers and 5 labels. So I'm going to create a pie chart. Okay. So the values will be A, and then there will be labels. So you can see here 5 labels have been created. 5 the pie chart, 5 parts have been created, and yeah, this has gone anti-clockwise, right? So the default value that they have taken is anti-clockwise. So apple, banana, grapes, and orange and pineapple, right? So if you want to plot this on the other way around, you have to mention it, like in here. Right. So the colors also you can give standard colors. Yeah, so there are certain functions to give colors. So you can see here rainbow is one set of color. So like that you can change the, you can customize your pie chart. Okay, so you can also include a legend like this. So here you can see mm, mm, mm. So this is the color. Yeah, this is the legend. So you can see here, this is how you have to write the legend. So this is where to include the legend on the top right, and this is what you are going to write inside the legend. So the colors, they will take the default colors, the colors which they are using in the pie chart, they will take it, and the labels you have to give them, right? Right. You can also create 3D pie charts like this. You can try it. So pie 3D, the keyword will be used to create this chart. Okay, so that is how you are going to create pie charts in R Studio. So similarly, you can create bar charts right? So it is the keyword is bar plot. You can use it to create bar charts like this. So in bar charts also, the first one will be the vector or the set of data. So xlab means the label, the name of x-axis. Ylab means the label for y-axis. Then the main means the name of the chart, and this is the names which appear under each bar, right? The names which appear under each bar, names dot or arguments. And then you can give colors to the bars in the graph. So here you can see an example. So you can always go to this link in tutorials point and you can refer to these examples, right? So there is a box plot as well. So I'm going to give you this link. I'm going to send this link to you regarding box plot. You can try, right? You can try this example because it is good if you can include a box plot in your assignment. If it is okay, if it is relevant to the question that is given to you. So you can go through this example here and try to build a box plot. So these numbers and yeah, the data you can include how they have given here. Right. So I'll send you the link, or you can always go to the tutorials point and get R tutorials point in R. Right. So I have sent you the link. So you can go to this link and try to build a box plot using the values given here, using the examples given here. Okay, so I'll give you a bit of time for you to try. Yeah, so were you okay doing the box plot? Do you have any other questions that you need to clarify?
Box plot is okay, ma'am. Not
Okay.
issue.
Okay. So yeah, you have other charts and graphs that you can use in your assignment. So histograms, we talked about it. Line graphs are pretty much simple. It is a pretty simple graph. So you can use the data set and uh, the type, like how to draw the line graph, whether to draw it with the points, data points, or only the lines, or whether to draw it using both the points and lines, so like that. Then the colors and the x and y axis, you can mention them, right? And scatter plots is also a way to represent data. But I actually encourage you to either include uh, pie charts, bar charts, box plots, or histograms. So box plots and histograms are the most successful data representation methods, because you can uh, describe a lot of things using those charts, but you can also use bar charts and pie charts, even line graphs if you like, if it is relevant to your data set. I mean, the chart, the type of chart that you are using should show or should resemble the best description of your data set. You should be able to describe your data set in a very clear manner using the relevant chart that you have selected. Okay. In R, there are also some examples regarding statistics. So these also will be very important. So the first one, which is included, is the mean, median, and mode, right? So this, I mean, you do not need to separately apply these functions, because in R you have something called a summary. So they already calculate and give you a summary which includes all these mean, median, and the maximum, minimum values. So that those values will normally be enough. But if you need to include, I mean, if you need to find the median and include it in your uh, assignment or in your description, that is okay. So you can, there are certain options uh, which where you can include the mean uh, and then the median, right? So this is the data set. So the keyword median, median dot result, or median can be used to, sorry, median dot result is your variable name. The median is the keyword. So you can use the median function and compute the median of a given data set. You can also compute the mode, right, of both the numerical values as well as character values. So if you have a set of characters and set of characters or strings, and if you want to see what is the word which is used most, right, which word is used again and again or most times, so you can use this mode function, right? Get mode. So like that, you have certain statistical functions where you can use them in your in order to describe your assignment, right? Right. So yeah, you can use regression functions. It is kind of linear functions that you can use. Linear regression, multiple regression, logistic. So you do not have to go through all of these. I mean, yeah, you are not required to go through these all of these statistical examples. I mean, these functions you might not require to do, but please make sure you are familiar with these charts and the basic syntax, uh, decision making, those kind of things, right? So, right. So in RStudio, there is an option to make a heat map also. So you can make a heat map. If you can remember, we made a heat map on the last week, I think, in QGIS. So you can, in RStudio also, you can make a heat map. But before that, you have to install a certain package. So if you have just installed RStudio in your machine, this package does not normally comes in a default manner. So if you want to check whether you have this gplots package, so this is the package that you are required to have with you in order to create a heat map. So check whether you have gplots package. So first of all, you can check for installed packages. So you can type this function here, installed.packages, and see whether you have gplots package in your list. If you do not have it, you have to install it. So you have to type this command, install.packages, and inside it you have to type gplots. So this package will be downloaded and installed automatically in your application, in your machine. Then you have to enable the package. So you have to call this function library and the gplots, right? So if you want to create a heat map, before creating a heat map, you have to call this function. You have to perform each time you start up RStudio. So let's say you work with gplots today and you switch off your or you close your RStudio, and on the other day you have to again call for this gplots library, right? Okay, so this is how a typical heat map on RStudio appears. So here what I have done is I have created a data matrix using a certain file. So you can take maybe any set of data that you have, and you have to load it to a matrix. You have to convert the data set to a matrix, and then you can point, or you can give a name to that data set. It is like a variable name or a pointer. Then the function is heatmap.to, right? Heatmap.to. So the data set is this one. The first of all, you have to write the data set. So it is here, Z is the data set. Z include this the data inside this file, right? Then main means the name of the heat map. Trace none means yeah, this is a kind of a default value. and these are the margins of your heat map. So this household size, state something, country, geography, these are the things which come as column names in the data set, right? These are the ones which are there as column names in the data set. And these are the values, right? These are the values which come under the heat map. Values which are there in the file. So this is how you can create a heat map, right? So you can change the color of the heat map according to the clarity. So you can remember in QGIS also we changed a lot of settings, a lot of colors to finally obtain the optimum heat map, right? The heat map which is very clear for us. So here also you can use certain color palettes. So here the color ramp palette, I have used yellow and blue. So these yellow and blue are keywords. Color ramp palette means it is the set of colors that you are using. And I have named this color palette as YB. So YB is my variable name. So when you are creating the heat map, you can include this color into this color variable. You can include the color ramp palette, which is YB, right? So main is the name, right? So like that you can create heat maps which are clearly visible. So it is up to you to change the colors and see how what is the clarity of the heat map. So I have also included some two links actually. One is a YouTube video which includes uh, examples for programming in R for beginners, and the other one is the tutorials point link, right? So you can use those two links and you can create certain statistical summaries in RStudio, right? So remember, you do not need to go very further down, but try to focus on statistical functions like standard deviations, creating histograms, creating heat maps, things like that. The mean, median, the summary, those kind of functions, they are the most important ones that you can use in your assignment, right? Okay. Any questions regarding RStudio? So the thing is, you have to practice this. You practice the basic functions and come to these uh, functions where you are able to represent the data, right? Be familiar with functions where you are able to represent the data. So heat map, you are able to represent the data. Okay. Okay. Any questions? Okay, so by now you are able to do the questions which are related to RStudio. I think the first and second questions you can in your assignment you are able to do by now. So you can do them, you can analyze them in RStudio. So I think they have required you to create certain CSV file by including data from the PDF files that they have sent you, right? So you have to create the CSV file and you have to load that CSV file into your RStudio uh, environment, and you can uh, do the analysis part. And after the analysis, it is better for you to represent the final outcome either using certain charts or heat maps. Okay, so so that is all about R. Okay, so since you do not have any other questions, I'll start doing PostgreSQL example from the next week onwards, but I'll simply uh, go I'll take you through the installation process and how you have to uh, prepare your background or your environment to work with PostgreSQL. So make sure you are ready with this environment by the next week. So in the next week we will start doing some practicals regarding PostgreSQL. So basically, what PostgreSQL is, it is an open source relational database management system. So you already know what a database management system is. I hope you have done MySQL by now. I'm not sure about any other database management systems, but MySQL is the most widely used uh, structural query language, actually. So PostgreSQL is also a structured query language. The difference is you can use spatial data in PostgreSQL. Unlike in MySQL or any other query language in any other database management systems, you can use um, spatial data in PostgreSQL. So PostgreSQL runs on all major operating systems. So in any operating system, including Linux, Unix, Windows, you can use PostgreSQL. In PostgreSQL, it supports text, images, sounds, video, and includes programming interfaces also for C and C++, Java, Perl, Python, and those kind of programming languages, right? So using these programming languages, you can access PostgreSQL as well, right? So why do we use PostgreSQL? So it is basically an object relational database. MySQL is purely relational database. So in PostgreSQL, we are handling things as objects, right? We are handling things as objects. So this means that PostgreSQL includes features like table inheritance and function overloading, which can be important to certain applications. PostgreSQL also adheres more closely to SQL standards. So it is pretty similar to SQL. The standards are quite same. PostgreSQL is feature rich. There are a lot of features that you can use in PostgreSQL. It natively supports NoSQL as well as a rich set of data types, including numerical types, Boolean types, network addresses, bit string types, arrays, composite types, object identifier types, pseudotypes, and even geometric types like points, lines, segments, boxes, paths, polygons, and circles. So you can see here there are a lot of data types which can be used in PostgreSQL. I think in MySQL, only text, numeric types, Boolean types. I'm not sure about network addresses, but they might be able to use network addresses in MySQL. Arrays. Uh, so it is quite limited in MySQL. Obviously, geometric types like points, lines, boxes, paths, polygons, and circles cannot be used in MySQL. So in PostgreSQL, you can see it is feature rich. So a lot of data types can be used in PostgreSQL. Postgres users include some of the biggest users of enterprise data, including Apple, Cisco, Facebook, Fujitsu, Instagram, Macworld, Spotify, Yahoo. So these enterprises, they use PostgreSQL in their uh, applications, in their products to as a database management system of their products. They use PostgreSQL. So, for example, Facebook might need to use PostgreSQL to maybe deal with location data, right? Like that. So, PostgreSQL support a large part of SQL standard and offers many modern features, including the following. So, there are certain features which is offered by PostgreSQL. Uh, Complex SQL queries, you can write complex SQL queries, SQL subselects, foreign keys, triggers, views, transactions, multi-version concurrency controls, streaming replication, hot standby. So you might not know all of these things. That is okay, right? You might not know or understand everything, but I think you know what a view is, because in MySQL also you have views. You might have triggers. Yeah, in triggers, sorry, in MySQL you have triggers also. Foreign keys are there in MySQL. So you can see, so these are some features which are there in MySQL. So apart from that, there are some other features also. Yeah, in MySQL, it also supports complex SQL queries. Um, so this multi-version concurrency control and these things, I'm not very much familiar with it, but you can always go and search and see what they are. So maybe MySQL is supporting these things by now. Uh, However, in PostgreSQL, they support a lot of, I mean, they have a lot of features which are offered by PostgreSQL. Okay. Okay, so first of all, you have to download PostgreSQL and install it. So you can freely download PostgreSQL. So here I have installed PostgreSQL 9.4, right? So when you install this set of applications are available in your machine. So the application stack builder, installation notes, pgadmin 3, and the SQL shell will be installed when you install PostgreSQL, right? So after installing PostgreSQL into your computer, you have to connect to a PostgreSQL database server. You have to connect to the server. So when you install MySQL, you have to run the server, right? MySQL server. So here also, after installing PostgreSQL, you have to connect and run the PostgreSQL server. For that, you have to use this pgadmin application. So you have to launch the pgadmin application. So remember, this is after you install PostgreSQL into your machine. When you are installing the PostgreSQL, make sure you install all of these. These applications. Normally, they are installed in a default manner. So this application stack builder, pgadmin, SQL shell, those applications will be installed in the default way. But if somehow you are given the choice to select what you need to install, make sure you install all of these things, right? So when you load pgadmin, when you open pgadmin, it will be seen like this. The pgadmin application will launch on the web browser as shown in this picture. So you can see the pgadmin application will be loaded. So you have an option like this to add a new connection. So remember, sometimes in maybe in newer versions or maybe in different versions, you might not see the exact icons in the exact places that I have shown here, right? So you might go to the application and try to locate this icon in this place. Sometimes you might not get it, but you can always search. The thing is, you have to add a new connection. So a similar different way is there to do the same work, right? So however, you have to add a new connection. uh, for that you have to create a new connection. So when you click on this icon, or when you go to adding a new collection option, yeah, you will be shown with this kind of window, right? So I'm showing you this here because I have already installed PostgreSQL in my machine. So I'm not able to reinstall it. So you have to enter the uh, details like this. So the name will be PostgreSQL. Uh, the host will be localhost. You have to include localhost here. The port will be already given to you. They will select the existing port in your machine and they will give the port. Maintenance database should be Postgres. Username, username will be Postgres. And remember the password when you are installing PostgreSQL in the previous step, when you are installing PostgreSQL, you will be asked uh, a password, right? A password will be required. So enter a password that you can remember, and that password should be used here, right? So you have to enter the same password you gave when installing PostgreSQL. So make sure you give a password that you do not forget, because it will be required in several places when you are using or when you are creating new connections in PostgreSQL. Uh, so remember the password. So you have to enter that password. You can either save the password or not, that is up to you. Then you have to save this connection. So you have to add the connection in this manner, right? So save this connection and the connection will be created. Your PostgreSQL connection will be created. So the connection will be, when the connection is added, you can see one server will be running. So under that server, you will see databases. So since you haven't created any databases, you won't be able to see databases which are created by you. So there is one database by default which is named as Postgres. So PostgreSQL has one database by default where the name is Postgres, right? So if you want to do queries, there is an option called, so you can click on this icon. It is like a lightning icon. You can click on this and you can open the query tool, or otherwise you can go to tools, and under tools there is a query tool. Okay, so either you click the lightning icon or either you click on query tool, you can open the place where you can type certain queries. So here, this is the query editor. I mean, a new window will be opened when you click on query tool or the lightning button. So here, you can open a new query editor. Then you can execute. So there's an execute button here, right? So this is the execute button. Then your results will be seen here under the data output option. Your results will be seen here. So you can see I have typed the select version command, and the PostgreSQL version will be appeared here. So I haven't created any tables or anything here, just a simple query to make sure this is working, right? Okay, so that was the first method. So the first method was you can use pgadmin in order to create a new connection, or in order to connect PostgreSQL database server. So this is the second method. So you can see here, this is the method 2. You can use the shell, SQL shell, to create a PostgreSQL database server, right? So you are using PSQL here. So you can launch the PSQL program and connect to the PostgreSQL database server using Postgres user by clicking on the PSQL icon. So you can open this shell and then you have to type these commands. So you have to, I mean, they are asking the server, database, port, username, password, the same things, the same the same form which appears here, they are asking in the command shell as well. So you have to include those the detail. You have to enter the necessary information, which are server, database, port, username, and password. And you have to press enter to accept the default. You can press enter to accept the default. You need to enter the password that you set up during the installation. So here also remember, you have to include the password which you gave when installing PostgreSQL, right? So after providing all the information, you can start working in PostgreSQL. So you can interact with the PostgreSQL database server by issuing an SQL statement. You can try the following statement to test it out. So you can use this SQL statement to test whether this connection is working correctly. So here, remember, you have to use a semicolon after each and every command. After pressing enter, PSQL will return the current PostgreSQL version that you have in the system. So that is the result for this query. Okay, so yeah, so afterwards you can create tables. You can create a new database, right? You can load a database using pgadmin. I mean, you can load an existing database. So first of all, you have to create a database. So you can go to this databases option, and you can simply right click and create a new database. You should give a name for the database, and then you can create the new database. So this is the new database that I have created. DVD rental is the new database that I have created. So if you already have a database in your machine, which was created in maybe somewhere else, or sometime earlier, you can restore that database into the database that you have created here. So you can simply right click on DVD rental and click on restore. So here, the database which is already there in your machine will be copied or will be restored to this DVD rental database that I have created. Okay. Or otherwise, you can, yeah, here you have to provide the path to database file, and you can click on you can click on restore button. So when you open the DVD rental database, which I have imported from somewhere else, you can see there are certain objects here. And there is one option called schema. And under that schema, there is an option called public. And under the public, there is an option called table. So this table is the tables. This tables option includes all the tables which are there in the DVD rental database, right? Actor, address. So those are the tables, right? Okay. So how to use spatial data in PostgreSQL, I will be doing on the next week along with all the other what do you say, examples or data that we have. And you need to install something else when you want to create when you want to deal with spatial data in PostgreSQL database. So I will leave this to do on the other day. Otherwise, you will be confused with all these things. So try to install PostgreSQL and change the settings that I have that according to how I have given to you, and try to build a table or try to uh, load a database to your workspace, right? So you can go through up to this point here. I will send this lecture note as well to you, and you can go through these slides and see uh, how to load a data, an existing set of data into your database, right? And how to query the data and using spatial data in your database, I will be doing on the next day because it is quite a long topic here, right? So in the meantime, you can be ready with PostgreSQL. You can install PostgreSQL in your machine, and you can create a new connection, create new databases, and query certain queries, right? You can be familiar with them. And on the next week, we will talk about using spatial data in PostgreSQL. Okay. So I'll send this handout as well in your chat. Okay, so this is the PostgreSQL handout. So I'll send it in your I'm sending it in your chat. Okay, so when you get it, you can share it with your colleagues as well. Yeah, I have sent it. So so any questions related to what we did today? Do you have any questions? Do you have any questions related to what we did today? Okay, so if it is okay, if you do not have any issues, we can conclude for today. We will stop for today. And we will continue on the next week. Okay.
Okay, ma'am.
Okay,
Thank
thank
you.
you.
Thank you, ma'am.